So in this section on advanced algorithmic analysis, what have we learned?
Well, we learned a bunch of stuff. It's kind of I'm going to say a compact and dense lesson. I think that's pretty good.
Oh, that was a math joke, wasn't it?
Yes, it was. It was a math joke. Well, first thing we learned is that you like alliteration. This whole section was advanced algorithmic analysis.
Okay.
And in particular, we talked about three things, all ending in I: VI, LI, and PI.
Yeah, there's a problem with LI, though.
Yeah, that's not really a thing.
Yeah, it's LP, linear programming.
But then it wouldn't end in I.
I agree with that, but at least it ends with P, and the other one starts with P. So there's some overlap. All these things overlap with each other.
Well, if you call it a VLP for very linear programming, then you get...
Yeah, no, it's just linear programming. Let's just go with that.
Okay. All right. I mean, very linear is still linear. In any case, all right. So what did we learn? So we learned a little bit about each of those things. So particularly for value iteration, we learned that it converges to optimal in finite number of steps, or, gets bound towards that.
Okay, can we be more precise there? The value function doesn't converge in a finite number of steps.
But the policy does.
The greedy policy does, yeah.
Right. But really, that's what we want.
Yeah, I agree with that.
Sure. But that's a good point, that it's not that the value function itself has to, because otherwise we'd go all the way back to EM and have that conversation again. But that the policy itself will stop changing. The greedy policy will stop changing at some point and in finite time.
Right. And it'll be optimal at that point. Yeah, and the value function itself doesn't necessarily converge, but it's going to get boundedly close to the solution. So that is to say, if we want to be epsilon close to the solution to the Bellman equation, we can define how many iterations of value iteration we would need to accomplish that degree of approximation.
Right. And that's fine, because in the end, that's interesting. But what's really interesting is that we get a policy that we can act on.
Because we want to maximize reward. That's just what we're about.
That's what we're all about, really. So let's see. Then we talked a little about linear programming, which is yet another way to think about solving MDPs. And what I remember most about it is you actually defined the dual.
Okay.
And that was really cool because it allowed us to solve the problem. And like so many things that we do, it was a callback to our first class. And now I actually understand how support vector machines work.
Okay. I think you did that lecture, so I'm hoping you understood it already.
Well, there was just a point where you said, well, or you could solve the dual. And then I rapidly waved my hands and said, don't worry about it. It's a dual. It's a thing.
Okay.
But now we talked about the dual, so I think that that's good.
I feel like the concept of dual is somehow relevant to superheroes.
You think so?
I don't know. Like, you know way more about comic books than I do, but isn't there I
do.
Every superhero has a dual, like anti-Batman or the Dark Spider-Man?
Venom? So you're saying that primal and duals are they're like nemesis.
Yeah, or mirror images of each other in some way.
So the flow, the sort of policy flow idea, is like the nemesis of the value idea, or the mirror image of it.
Yeah.
Sure, let's go with that. I was thinking more of a hip-hop analogy, but I think that's pretty good.
Oh, flow is a hip-hop thing.
It's a hip-hop thing.
And values. People in hip-hop have values.
That's right. So it just follows in one step. Okay, speaking of one step, so then there's policy iteration, which I thought was kind of cool. We got a chance to prove a bunch of things about it, and I think the first thing we talked about there, or somewhere in that mix, was domination, which turned out to be really cool.
Yeah, and that comes up actually in all the algorithms. Value iteration has some of that, linear programming has some of that, and policy iteration. The proof of policy iteration depends pretty significantly on that.
Right. Speaking of things that the proof of policy iteration depends on, we also talked about value non-deprovement, or value improvement, I believe, is the non-technical term for it.
That's right. And we argued that we'd actually get strict value improvement anytime that we didn't have a policy that was already optimal. If it was already optimal, then a step of policy iteration resulted in value non-deprovement, which is just our broken way of saying it doesn't get worse. It might not get better, but it doesn't get worse.
Yeah, it's like a monotonically non-decreasing function. But the other thing is, we had a discussion that I think is actually pretty important, that when we talk about things like domination, we were writing them down for good notational reasons, talking about an entire value function, but really this is about things have to also be true on a state-by-state basis.
That's right.
Because if that weren't true, then in principle, you could cycle, and then you could get stuck in local optima. But here, we don't get stuck in local optima because things also dominate on a state-by-state basis.
Cool.
Kind of neat.
Yeah.
So we also talked about monotonicity.
And that you can contract it from kissing.
Yes. Oh, you said contract. Very, very well done, Mike.
Oh, yeah, that was Pun intentional, sorry.
Unintentional. Okay, and really when you put all those things together, I think the real thing that we learned in this lesson is that proofs do not suck.
So that's great because if I recall, we started our last class with a little discussion about how I don't mind proofs as much as you do.
That's right. Speaking of proof, you forgot the S on proofs. No. See, I did a proof of your proof. That was pretty good.
Oh, you proofread it.
Yes, yes.
Nice.
Oh, I feel like we've converged.
And that's what this was all about.
And that's what this was all about.
Yeah, there's something very satisfying about getting to the convergence point.
Very nice, very nice. Okay, well, I think that's everything that I was capable of learning in one lesson.
Yeah. All right. Well, so yeah, next time we'll start in with something else. I think we're going to talk about how we can modify reward functions and get different things out of them.
Oh, yeah, that's my favorite. Excellent. Well, then I will see you then.